Objective number 2. Find the domain of a function involving a radical. We base on the index to find the domain. If the index is even, then the radicand is the number or the term under the radical, must be greater than or equal to 0. And if the index is odd number, then the radicand can be any real number. So we will base on this to find the domain for example number 2. In example number 2, very important that we need to look at the index. The index for problem A is 2, is even. So what it says for the even is that the radicand must be greater than or equal to 0. The radicand is x minus 5. It must greater than or equal to 0. Then x plus 5 both sides, x greater than or equal to 5. You can answer the domain in the set builder notation like x and such that x greater than or equal to 5, or in the interval notation from 5 to infinity. In problem G, you can see that the index is 3, then the domain can be, the radicand can be any real number. So the radicand is 2x plus 1 can be any real number. Another, for the 2x plus 1 can be any real number, the value of the x can be anything. It can be positive, can be 0, can be negative. It will give 2x plus 1 be any real number. Then the domain will be negative infinity to positive infinity. So this is all value of x. In problem C, the index is 4, so it is even. Then we have to make the radicand, which is 5 minus 2t, greater than or equal to 0. We will solve for t, minus 5 both sides, then negative 2t greater than or equal to negative 5. We will divide by negative 2 both sides, and then you recall that you divide by a negative number. We will switch the inequality. Then the domain is all of the t values such that t less than or equal to 5 over 2 if you want to put your domain in the set builder notation, or you can answer from negative infinity to positive 5 over 2